Hello everyone. This video is just going to be a quick review of kind of the broad concepts we covered in this third block of the vectors part of the course. Okay, so I'm just going to go through a list and highlight some of the things that you expected to know, okay, and then talk about how you can prepare for the quiz. Okay, so the first thing we did in this section of the course, okay, was look at equations of lines. Right? We reviewed y equals mx plus b, but then we moved into representing lines with vectors. Okay, so there were three different forms of the equation of a line that we looked at. Okay, the first one was the vector form. Okay, so and the main focus is on three space. We did do it in 2 dimensions, okay, but I'm going to focus on 3 dimensions here. So, right, it looks something like this, right? My equation of a line is, right, so any point on the line, x, y, z, is equal to some initial point or position vector, x, y naught, z naught, plus t times some kind of a direction vector, m1, m2, m3. Okay. And again, the idea behind that is, right, if I have a line in space, okay, and I have, say, the origin over here somewhere, okay, this first part, right, that's the point on the line, so that gets me onto the line. Okay, and the second part, the direction vector, moves me along the line. So those are the two pieces you need, right? A point that puts me on the line and the direction vector to get moving along the line. Okay, so that's what the vector form looks like. Okay, the second form was the parametric form. Okay, and for this one, okay, really we just broke this into its different pieces, right? So I might write something like line is, right, x equals x naught plus t m1, right? Y equals y naught plus t m2. Z equals z naught plus t m3. Okay, right? So just taking each parameter separately and writing that out. Okay, there was a third form, okay, which we didn't use quite as much, called symmetric form. So what that form looks like is just taking your parameters and rearranging them to solve for the variable. Okay. So for the symmetric form, I use purple for that one. Okay. For example, if I took my first parameter and solved that for t, I would end up with t is equal to x minus x naught over m1. Okay. Similarly, y would be y minus y naught over m2, and z minus z naught over m3. Okay, and that's what the symmetric form of the equation looks like. Okay, so the other part of that being, right, these are the different forms. You need to be able to take different types of information and use that to determine the form. Okay, but again, all you really need is a point and a direction. So most of the time, you're going to either get the point and the direction vector, or maybe you get 2 points, and then you have to use those points to create a direction vector. But for lines, that was, more or less it for how you create them. Okay, then we did some different things with them. Okay, you have to be able to solve for the intersection of lines. Okay, and again, the way you do that is you take the parametric form of both, set the parameters equal to each other, and start solving for your different variables and see what you get. Okay, you need to be able to determine the distance between a point and a line. So, right, if this is my line, okay, and I have some point up here. Okay, how do I find, right, the shortest distance, so the perpendicular distance between the line and the point? Okay, so the way we did this, right, we found a point on the line, called it x. We found the vector running between the point, so we had the point A and the point x. Okay, then we projected the vector onto the line. Okay, and finally we use Pythagorean theorem to get what we wanted over here. Okay, so those were the steps. And again, if you need to review that, you can just return to that video and find it. But right, for point in a line, we found a vector running from the point to the line, we projected it, and then used Pythagorean theorem to find the distance. Okay, you need to find the distance between two lines. Okay, and here there are some cases. Okay, if you know the lines are parallel, then you use the point line method that we just discussed, because the only difference would be I have a line here instead of just a point, but I would have to do the same thing. Okay, find a point on this line, run it to a point on this line, project it, Pythagorean theorem. Okay, if you have skew lines, right, so they're not parallel to each other in space, okay, then you had to find a common normal, right? So the idea being I have one line running this way, another line running this way in space. Okay, it's 3D, they may be separated. So you have to figure out a normal that runs between them. Okay, once you have that normal, it's kind of similar kind of technique. You find a point on one line, you run it to a point on the other line, and then you project it onto that normal. Okay, and you find the common normal by doing the cross product of the direction vectors. Okay, that's pretty much sums up everything we learned about lines in vector form and three-dimensional space. Okay, so now planes. Okay, so again, we learned a couple different forms of the equation of a plane. Okay, we learned the vector form, okay, which looks like x, y, z equals. So again, we have some point, x naught, y naught, z naught. Then we have two direction vectors, t, a1, a2, a3, plus s, d1, b2, b3. Okay, and the key thing being these two direction vectors are not collinear, right? If this is my plane, okay, and there's my point, and then I have a direction running one way and a direction running the other way, and that's what defines a plane in three-dimensional space. So these two vectors here cannot be scalar multiples of each other. They have to be running in different directions. Okay, the parametric form of the plane is basically the same idea as the line, right? X equals x naught plus TA1 plus SB1 and so on. Okay, so the other one we focused on a bit was a scalar form. Okay, it looks very different. So it is something like AX plus BY plus CZ plus D is equal to 0. Okay, and this is where the normal to the plane is equal to A, B, and C. Okay, so for the vector form, right, you need a point and two directions that lie in the plane. For the scalar form, okay, you need to know the normal, so the vector that is perpendicular to the surface of the plane. Okay, and to figure out this constant, okay, you need to know a point on the plane. So depending what information you're given, that will kind of determine what form you have to start with, right? If you know the normal, then you're probably going to be doing scalar form first. If you know 3 points or a couple points in the direction vector, stuff that lies in the plane, then you're going to have to be starting with a vector form. Okay, right, to move from vector to scalar, right, you find the normal by taking the cross product of the two directions, and off you go. Okay, you need to be able to find the intersection of a line and a plane. Okay, right, and there's three cases, right? They can intersect in a point, they could not intersect at all if the line is parallel to the plane, or the line could lie in the plane and they have an infinite number of intersections. Okay, you have to be able to find the distance between a point or a line and a plane. Okay, and the technique for both is very similar, right? In order to do the line, it has to be parallel. Okay, so all you have to do for this one, you take a point on the line, you run it to a point on the plane, same idea, AX. Okay, you will be able to know what the normal of the plane is, okay, and then just project onto the normal, and you're pretty much there. Okay, you need to be able to determine the intersection of two planes. Okay, so the main case that's really important here, because it's a little bit new, right, is if you have two planes that go in different directions, okay, they intersect in a line. So you would need to be able to figure out the equation of this line. Okay. Okay. You need to know the different ways that three planes intersect, right? So again, we had a type 1, okay, where all three planes are parallel, so there is no intersections at all. Okay, there's type 2, where two of the planes are parallel. Okay, but the third one intersects the other two. Okay, so there's two different lines where it intersects, here and here. Okay, there is a type 3. And there's two subtypes here. This is when the normals are coplanar. So if you do the triple scalar product, you get 0. Okay, but I'll draw the profile version. Right, type 3A, if you looked at it from the side, looks like this. Okay, and there you just each pair intersects in a different line. Okay, you have 3B, okay, which is when this triangle collapses. So it kind of looks like a star if you look at it head on, and the three planes meet in a common line that runs down the middle. Okay, and finally for type 4, okay, this is where the planes meet in a corner. So I have like a plane like this, and maybe another plane like this. Okay, and I have a third plane that looks like this. And so there's this one corner kind of right in the middle here where the three planes meet, and there's a single point intersection. Okay, so again, we use the normals, right, to determine how this works. For these two, we look for normals that are parallel, so they have to be scalar multiples of each other. Okay, for these two, we check the triple scalar product. If it's 0, you have one of these types. If it is non-zero, you have one of those types. Okay, so again, that's kind of the really brief summary of all we've covered since the start of the third block of this unit. Okay, so for preparation, okay, practice quizzes are available on the website already. Okay, so feel free to have a look at those. Okay, and if you have questions about them or would like me to go over one of the solutions in detail so you can watch the steps, please, message and I can do that. Okay, and then on page 502 in the textbook, I just picked out a handful of questions there that practice some of the various skills that you need in this section. Okay, so again, practice quizzes for sure, and if you're looking for some additional practice, there are some questions you can look at, and feel free to ask about them. I could probably take up a couple each day as we go through the week. All right, thanks for watching, and I look forward to looking at your assignments and quizzes as they start to come in. Thanks.